Here we have the formula for the population variance. We're going to use this formula in order to work out the variance and standard deviation for this set of discrete data. In order to help us do this, let's look at the various parts of the formula. Mu we know is the mean, and therefore mu squared is the mean squared. Sigma x squared means the sum of the data squared. What I mean here is that we square each piece of data and then add them together. The n is the number of pieces of data that we have. Once we appreciate this, we can see that the formula is much easier to work with than the formula appears when you first look at it. First, let's look at the number of pieces of data. We simply have to count the number of pieces of data in our data set, and we can see that n is equal to 11. Now for the mean. To work out the mean, we add all of the pieces of data and then divide by the number of pieces of data that we have. So we start by adding all of the data together, and since we know there are 11 pieces of data, we divide by 11. And this gives us 82 over 11, and for now let's just leave that as 82 over 11 rather than calculating it and getting a long decimal. We now want the sum of the data squared, so we take each piece of data and square it and then add them all together. So 3 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared, and so on, right the way to the end of the data. This comes to 736, and now we have all of the things we need. The variance is going to be the sum of the data squared, which we've found to be 736, divided by the number of pieces of data, take away the mean, which was 82 over 11, squared. If we calculate this, we get 11.34, correct to 2 decimal places. For the standard deviation, all we need to do is take the square root of this result, and we get 3.37, correct to 2 decimal places.